Okay, I did not have one of these saved, so I'm going to make it real quick. Bell's probably going to ring while I'm talking, but I feel bad that you guys got shafted on the last one. So this is a quadratic inequality. So hopefully you recognize that x squared minus 6x plus 8 is a parabola. And we're going to look at it on the calculator real quick. X squared minus 6x plus 8. X squared minus 6x plus 8. So there's the graph. And just to remember, I'm going to go zoom 6 to get my 10 by 10 window. Zoom 6. I think I typed something in wrong. X squared minus 6x plus 8. Why doesn't that look very good? X squared, oh, see, I wrote times 8. See, we all make calculator mistakes. Plus. Now it should be a nice little parabola. The question is asking me to find out in which interval is this graph greater than 3. When is this graph greater than 3? So I'm going to put 3 into y2. And you can see that it's greater than all the way up until here, and then from here to the right. That's when it's greater than that's when the blue is bigger than the red. So in order to figure out what these 2 points are, I'm going to go second calc intersect. 1 and arrow over. Enter, enter, enter. 1 and 5. So my answer to this would be the blue line is greater than the red line from negative infinity to 1 union 5 to infinity. Let me write that down. The answer to this is from negative infinity to 1 union 5 to infinity. Now, if you're not familiar with this notation, we're going to talk about it. It also can be written as x is less than 1 or x is greater than 5. Hopefully that makes sense to you. Well, that's all well and good that we can do it on the calculator, but what if this was something that we needed to do without a calculator? Well, just like with any quadratic, we want it to equal 0, so we're going to subtract 3 from both sides. So we have x squared minus 6x plus 5 is greater than 0. That's a plus. It's a minus. Factor x minus 5 and x minus 1. Now, I don't want to say x equals 5 and x, well, yeah, I guess I do. So draw your T. X equals 5, x equals 1. Now, the easiest way to figure out what the answer is based on this is to draw yourself a little number line and put the numbers on there. Those are called critical points. Those are where this changes, where it goes from being greater than to less than. Remember, if you look at the graph, at 1, the blue line goes from being bigger than the red line to being less than the red line. And at 5, it goes from being less than the red line to bigger than the red line. So whatever happens on this side of 1 is going to happen to all of these numbers. And whatever happens in here is true for all of these numbers. And whatever happens over here is true for everything bigger than 5. We just have to figure out where it's true. So if we were doing this algebraically, like I said, with no calculator, we would take numbers on either side of 1 and 5. So here's 1, here's 5. We're going to test 0, 2, and 6. Any number to the left of 1, any number in between, any number to the right of 6. So if I plug in 0, now I could do 0 stow x if I wanted to. 0 stow x, enter, and I'm looking at x squared minus 6x plus 8, and that's positive. So this is positive, which is greater than 0, which is what we want. Oops, sorry. I need it to be greater than 3 because I typed in this function. If I had typed in this function, I would have looked for greater than 0. But I'm looking for greater than 3. 8 is greater than 3, so it's still true. So everything to the left of 1 is true. So I know that x is less than 1 is one of my possible solutions. Now I'm going to try 2. So I'm going to go 2 stow x, only 1 stow, enter. And then I want to get this function back in, so I go up to that and I push enter. I push enter again. That's 0. Now 0 is not greater than 3, so this is not true. And then if I try 6, back in the calculator, 6 stow x, enter. Put my entry in again, so I'm going to hit enter, enter again. 8, so that is greater than 0, so this is true. So everything greater than 5 is also true. So that's algebraically how you get that answer. We also could have done the algebra first and then typed this in to see where it's positive. So let's make that a plus 5. Notice that it's above the x-axis. The function is positive from negative infinity all the way to 1, and then from 5 all the way to infinity. Remember, when we talk about these, we're only talking about the x value. We want to know for what x values is the graph positive, negative, or whatever we're asking. Let's try the next one. This time it's a different problem. I thought it was the same problem. Okay. We want to know when is x squared minus 4x plus 1 greater than 6. Well, let's look at what the answers are. X squared minus 4x plus 1. And then I'm going to put 6 into my y2. Look at the graph. When is it greater than 6? Looking for greater than. Well, it's greater than up to here and from here on. So I have to find what those 2 points are. -1 and 5. So from, why is it doing this to me? From negative infinity to -1, and from 5 to infinity. But let's check it algebraically. So -6 factor and then draw your t. So 5 and -1 are our points. And we are going to check -1 and 5. So let's try points -2, 0, and 6. Those are just in each section of that. So go to the calculator. Let's plug in -2 stow x. I'm going to show you another trick. Hopefully you've watched up until now and you're listening, because this is a really cool trick. I want to test -2 into this y1 function, and I want it to be greater than 6 for it to be true. So on my main screen, I'm just going to push alpha trace, and I can pick y1, which is the function I'm talking about, and it plugs 2 in for me, and I get 13. I'll show you what I'm doing again. Remember that y1 is x squared minus 4x plus 1, which is this. When it's greater than 6, that's the solution to our problem. So I want to know if I plug in 0 for x, 0 stow x, and if I want to evaluate it at y1, I get 1, which is not greater than 6, so this is not true. And then I'm going to try 6. I'm going to store 6 in x, and I want to evaluate for y1, and it's 13, which is greater than 6. So it's true this way, and it's true this way, just like our graph showed us originally. Let's see what else we got here. This one you're going to want to divide by -1 in order to get your leading coefficient positive, because we don't ever want to deal with the leading coefficient of a negative. However, when you do that, don't forget you have to switch the sign. So on your homework, I think it actually says graph this, which I don't really want you to do, but I'll show you how to do it anyway, because that's what the homework says. I want you to be able to solve it algebraically. I don't really care if you can graph it. I really do care if you can graph it on the calculator, so let's show you how to do that. Okay, so why can't I move this? Whatever. 2x squared minus 3x minus 6. 2x squared minus 3x minus 6. and I want to know when that's negative, when it's less than 0. So how can I do that? I thought there was a way to color it in, but I guess not. When is this less than 0? Well, it's less than 0 right in here. That's when the function is negative. Ah! That's what it means to be less than 0, is to be negative. So you would say, if you had to graph it, you would just show the graph and then you would color it in right there. But let's do it algebraically, because that's what we really care about. Okay, so we're going to factor this. Go away. So I'm going to try, this is really messy. I need to start over. When is 2x minus 3x minus 6 less than 0? So let's try a 3 here and a 2 here, which will never be true because that would be a common factor. So forget that. Just switch the 3 and the 2 around. Which gives me 4 and 3, which isn't going to give me a 3. 6 and 1. Nope, that's not going to work. Maybe this isn't factorable. Is that possible that this isn't factorable? I would never do that to you. But let's try the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Yeah, this is nasty. Okay. 8 times 6 is 48. 9 plus 48 is the square root of 57 all over 4. I don't want to figure out what that is. So my answers are 3 plus the square root of 57 all over 4. And 3 minus the square root of 57 all over 4. Now you can get a decimal there if you want, but I like it like that. However, those aren't my answers because remember I have to have intervals on my graph because I want to know when is it negative. So hopefully you can type this in your calculator. 3 plus square root 57 divided by 4. So about 2.63. This is probably the bigger one. And then 3 minus. Negative 1.13. Yep. So I'll put 2.63 here. And I'll put negative 1.13 here. So again, I'm just going to check one critical point. I'm just going to check 0. If 0 is true, then your answer is between here and here. If 0 is false, then your answer goes like that. So let's check 0. And remember, I put my function into y1, 2x squared minus 3x minus 6, right? 2x squared minus 3x minus 6. So I put my function into y1, so I'm going to check 0. 0, stow, x, enter. And then alpha trace y1. And I'm afraid it's going to give me 0, which, nope, negative 6. Since negative 6 is less than 0, this is true, so your answer is in between negative 1.13 and 2.63. So in interval notation, we would write it like this. Actually, I would use these. I would say 3 minus root 57 all over 4, comma, 3 plus root 57 all over 4. Let's just go over what this means again. These are two numbers. In between these two numbers, this graph right here is negative. Let's just check it. Oh, remember I told you how to put in 0 for y2 so that you don't have to do the zeros? That's a huge trick. Up, up, second calc, intersect. Oh, I think I pushed 0. Enter, enter, enter. negative 1.13. Second calc intersect. Enter, enter, enter. 2.63. Same numbers we got, and you can see that it's below the x-axis in between those two numbers, which is what it means to be negative. Awesome. Well, I think what's going on? We'll just call that a day. So on your homework it says to graph basically whatever it is, you graph the parabola, and then if the numbers inside it are true, you shade inside, and if the numbers outside it are true, you shade outside. But I'd be much happier if you just did the algebra like this. That would mean you learned something. Okay, happy day.